Imagine pulling on a simple rubber glove before a medical procedure, a laboratory experiment, or even washing the dishes. It stretches effortlessly over your hand, protecting you from invisible dangers that could change a life in seconds. But here's what nobody tells you. That thin layer of rubber has traveled thousands of miles, survived scorching heat, dozens of chemical transformations, and passed some of the toughest quality tests in modern manufacturing. Today, you're about to step inside one of the world's most advanced factories and witness how nature, chemistry, and precision engineering come together to create billions of gloves every single year. Think about this. Every day, hospitals around the world use hundreds of millions of disposable gloves. During global health emergencies, demand can skyrocket beyond 1 billion gloves every single day. Entire factories run around the clock without stopping, while endless rows of robotic production lines quietly transform liquid latex into life-saving protection. Most people never see this hidden world, yet countless lives depend on it. And this is where it gets truly extraordinary. A single production line can carry more than 30,000 ceramic hand molds at the same time. These artificial hands travel nearly a kilometer through ovens, chemical baths, drying tunnels, inspection stations, and packaging systems before a finished glove finally reaches a box. What happens next surprised even experienced engineers, because the most important ingredient doesn't come from a laboratory at all. Our journey begins deep inside the tropical forests of Southeast Asia, where the rubber tree quietly produces one of nature's most remarkable materials. Countries like Thailand, Indonesia, Vietnam, Malaysia, and India supply most of the world's natural rubber. Before sunrise, skilled workers walk through neat rows of trees, carrying nothing more than a sharp tapping knife and small collection cups. Every careful cut allows the tree to release a milky white liquid called latex without harming it, making the same tree productive for more than 25 years. Imagine standing beside one of these trees as fresh latex slowly drips into the cup below. It looks almost like milk, but it's actually a suspension containing tiny natural rubber particles, water, proteins, sugars, and minerals. Fresh latex usually contains only about 30 to 35% rubber, while the rest is mostly water. Within just a few hours, bacteria would naturally begin breaking it down. So workers quickly add a tiny amount of ammonia to preserve its quality before transport. The freshly collected latex now begins an incredible journey. Tanker trucks transport thousands of liters from remote plantations to processing centers, where giant stainless steel tanks gently stir the liquid to keep every microscopic rubber particle evenly suspended. Centrifuge machines spinning at nearly 6,000 revolutions per minute concentrate the latex until it reaches roughly 60% rubber content. This concentrated latex forms a foundation for premium medical and examination gloves. But natural latex alone cannot become a durable glove. Scientists carefully blend sulfur, zinc oxide, accelerators, stabilizers, antioxidants, pigments, and specialized surfactants into the mixture. Each ingredient performs a unique job. Sulfur creates microscopic bridges between rubber molecules during heating, giving the glove its remarkable strength and elasticity. The entire recipe often varies by less than 1%, yet even tiny adjustments can dramatically change how the finished glove feels and performs. Most people never think about this, but every shipment undergoes strict laboratory testing before entering production. Engineers measure viscosity, pH, total solids, mechanical stability, particle size, and contamination levels. Even a tiny variation could cause microscopic holes that no human eye could ever detect. Rejecting an entire tanker of latex costs thousands of dollars, but producing unsafe gloves would cost far more. Rubber isn't the only material arriving at the factory gates. Massive shipments of calcium nitrate solution prepare ceramic hand molds for dipping. Cornstarch or polymer coatings help workers remove gloves after manufacturing. Cardboard for packaging arrives by the truckload, while high-purity water flows through sophisticated filtration systems because even tiny mineral impurities could leave visible defects on the finished surface. Every supply chain operates with almost military precision. Producing natural rubber also brings serious environmental challenges. Expanding plantations can threaten biodiversity if forests disappear, while processing wastewater must undergo careful treatment before returning safely to the environment. Many leading manufacturers now recycle processed water, recover heat from factory ovens, and source latex from certified sustainable farms. These improvements reduce energy use while protecting the ecosystems that make natural rubber possible in the first place. Now every ingredient has arrived. The latex mixture has been perfected. Thousands of ceramic hand molds wait silently on an endless conveyor stretching farther than the eye can see. In just a few moments, these lifeless hands will enter a production line, so precise that a difference of only a few seconds can determine whether a glove protects a surgeon or fails completely. And what happens inside that factory is unlike anything you would ever expect. The moment the ceramic hand molds enter a production line, the pace never slows down. Thousands of porcelain formers glide overhead on a continuous conveyor at roughly 8 to 15 meters per minute, moving in perfect synchronization through every stage of the factory. Imagine standing beneath them as row after row of identical hands silently passes above your head, disappearing into clouds of warm steam. What looks effortless actually depends on split-second timing, because the very first step determines whether the glove will survive everything that follows. Before touching a single drop of latex, every ceramic hand receives a deep cleaning. The molds travel through high-pressure washing stations where jets of purified water spray at approximately 3 to 5 bar, stripping away dust, dried rubber, and microscopic contaminants. They then enter drying ovens heated to around 100 degrees Celsius or 212 degrees Fahrenheit for several minutes until every trace of moisture disappears. Even one tiny speck of dirt could leave a hole invisible to the human eye. Now comes a step most people have never heard of. The perfectly clean molds dip into a warm calcium nitrate coagulant solution maintained between 45 and 55 degrees Celsius, or 113 to 131 degrees Fahrenheit. A thin, invisible film coats every finger and every curve of the ceramic surface. Without this chemical layer, the liquid latex would simply slide off instead of forming a glove. The coated molds continue through another heated tunnel, allowing the coagulant layer to stabilize. As warm air circulates around each moving hand, workers constantly monitor temperature, humidity, and conveyor speed from computerized control stations. Everything must stay within extremely narrow limits. A temperature that's only a few degrees too low or too high can completely change the thickness of the finished glove. And this is where liquid rubber transforms into something you can actually wear. The molds slowly descend into enormous stainless steel tanks filled with carefully mixed natural latex, held between 25 and 30 degrees Celsius, or 77 to 86 degrees Fahrenheit. They remain submerged for roughly 5 to 15 seconds. During that short moment, calcium ions trigger the rubber particles to gather on the mold surface, creating a perfectly even film that will soon become a glove. What happens next surprised even experienced engineers. As each mold rises from the latex, gravity begins shaping the glove with incredible precision. Excess latex flows back into the tank, while the remaining layer slowly levels itself into an almost perfectly uniform thickness of around 0.10 to 0.20 millimeters. The factory doesn't waste a single drop. Pumps continuously filter and recirculate and use latex back into production system. For thicker industrial gloves, the process repeats. Some production lines perform a second dip after partial drying, building another microscopic layer of rubber. Others create textured fingertips by pressing the uncured latex against precision-engineered ceramic surfaces. Every extra second inside the latex tank changes the glove's thickness, flexibility, and strength. The gloves now look complete, but they remain surprisingly fragile. Long curing ovens stretching more than 100 meters heat them to approximately 110 to 130 degrees Celsius, or 230 to 266 degrees Fahrenheit, for 20 to 30 minutes. Inside these ovens, sulfur forms microscopic crosslinks between rubber molecules in a process called vulcanization. Think of millions of invisible bridges locking material together, giving the glove its famous stretch and remarkable resistance to tearing. As the conveyor leaves the ovens, the smell changes completely. The fresh scent of natural latex gives way to the warm aroma of cured rubber mixed with clean industrial air. Powerful ventilation systems quietly remove heat, while sensors constantly monitor airflow, temperature, and humidity across the entire production line. Behind the scenes, computers adjust dozens of variables every second to keep every glove nearly identical to the one before it. But the gloves still aren't ready for your hands. They enter a series of hot water leaching tanks where purified water, maintained between 60 and 80 degrees Celsius, gently washes away excess proteins, residual chemicals, and processing agents. Each washing stage lasts several minutes, and many factories repeat the cycle multiple times. This single process dramatically improves comfort while reducing the risk of allergic reactions in medical settings. Next comes a detail you've probably noticed without ever thinking about it. Rotating brushes gently roll the cuff of every glove into a smooth bead while the rubber remains slightly flexible. The machines spin at several hundred revolutions per minute, creating the familiar rolled edge that makes gloves easier to put on and far less likely to tear during use. It's a tiny feature that makes an enormous difference every single day.
Finally, compressed air and precision mechanical rollers peel each finished glove from its ceramic hand. One by one, they flip inside out as they fall gently onto fast-moving conveyors below. The sound resembles a steady rain of soft rubber, while robotic systems immediately separate leftover fragments from perfect products. Thousands of finished gloves now race toward inspection at speeds exceeding 40,000 pieces per hour on a single production line.
You might think the journey is over, but the hardest challenge still lies ahead. Some of these gloves will protect surgeons during life-saving operations. Others will handle dangerous chemicals or prevent contamination inside advanced laboratories. Every single one must now survive an extraordinary series of inspections where even microscopic flaws have nowhere left to hide. And that's where the factory reveals its most impressive technology. The production line may have created a glove that looks perfect, but appearance means almost nothing. Imagine trusting your life to a glove with a hole smaller than the width of a human hair. You would never see it, but bacteria and viruses certainly could. That's why the real challenge begins only after manufacturing ends. And every glove now enters a world where technology hunts for flaws invisible to the naked eye. The first inspection happens at astonishing speed. AI-powered vision systems photograph every glove from multiple angles as it races past high-resolution cameras at more than 40,000 pieces per hour. Advanced software instantly searches for tears, stains, trapped air bubbles, uneven thickness, roll cuff defects, and tiny surface imperfections. The entire inspection takes only a fraction of a second, yet performs thousands of measurements on every single glove. What happens next surprised even experienced engineers. Random samples leave the conveyor and enter automated leak testing stations filled with purified water or air. Depending on international testing standards, the gloves must hold a specific volume without leaking through microscopic holes. Some factories even use low-pressure air inflation systems combined with sensitive electronic sensors, capable of detecting leaks far too small for human eyes to notice. Strength matters just as much as airtight protection. Robotic tensile testing machines clamp both ends of the glove and stretch it until it reaches several 100% of its original length. Premium natural latex gloves can elongate by more than 700% before breaking, while sophisticated load cells measure every gram of force throughout the test. If the glove tears too early, engineers immediately investigate the entire production batch. Another laboratory performs microscopic thickness measurements, using precision instruments accurate to just a few microns. Engineers compare the fingertips, palm, cuff, and every individual finger against strict design tolerances. A glove that feels perfectly smooth to your hand may still fail inspection if one section varies by only a tiny fraction of a millimeter. At this level of manufacturing, precision becomes almost invisible. Most medical glove manufacturers also monitor what experts call the acceptable quality level, or AQL. Premium surgical gloves often meet an AQL of 1.5, or even lower, meaning only a very small number of defective gloves may appear within a carefully defined sample size. Every production lot undergoes statistical sampling based on internationally recognized inspection procedures. If the batch fails, thousands of gloves never leave a factory. Most medical glove manufacturers also monitor what experts call the acceptable quality level, or AQL. Premium surgical gloves often meet an AQL of 1.5, or even lower, meaning only a very small number of defective gloves may appear within a carefully defined sample size. Every production lot undergoes statistical sampling based on internationally recognized inspection procedures. If the batch fails, thousands of gloves never leave the factory. Certification adds another layer of confidence. Medical examination gloves commonly comply with standards such as ASTM EN 455, ISO 13485 manufacturing requirements, and, depending on the destination market, regulatory approvals from health authorities around the world. Every box carries batch numbers that allow complete traceability back to the exact production line, mixing tank, and manufacturing date. Imagine tracing one single glove all the way back to the rubber tree where its journey began. Despite all this incredible automation, one step still depends on human experience. Skilled inspectors stand beside the line under brilliant white lighting, turning gloves inside out, gently stretching fingertips, and feeling surfaces with trained hands. Years of experience allow them to notice subtle texture changes or tiny imperfections that algorithms occasionally overlook. In this moment, human intuition still beats even the smartest machine. Once approved, the gloves move into fully automated counting systems. High-speed robotic arms organize them into exact quantities before sealed packaging machines protect them from dust and moisture. Medical-grade gloves may continue into sterilization processes using gamma radiation or ethylene oxide, depending on product requirements, ensuring they remain safe until the moment a healthcare worker opens a box. Now step back and look at the bigger picture. The world produces well over 300 billion disposable rubber gloves every year, enough to give every person on Earth dozens of pairs annually. If you line those gloves fingertip to fingertip, they would stretch millions of kilometers, far enough to circle our planet many times.